So this project's going to be a bit of a challenge. We're going to be looking at how to reflect a point along a line. So what I mean by that is that if I have a particular line that looks like this, right, that's drawn across, I'm ruining it by drawing a squiggly line on top of a beautifully straight line. But say I have this point over here, point P. What is the coordinate of the point when I reflect it along this line? So what you can think of is that imagine you had this line, you have a point, and now you had this piece of paper that you took and you folded it on the line. So the line is at the crease of that piece of paper. Where would that point land when you folded that piece of paper, right? So imagine I'm folding a piece of paper along this line going across over here. And where does this point over here land? It lands over here. But how do we calculate what that coordinate is? And now this is useful for like all sorts of things, right? It comes up in game design if you've ever played Portal or something to the extent. It's a really important idea of knowing, like, if I have a shape over here, what is the coordinate or the reflected shape look like across here? And you get way more complicated with this, and it goes into 2D, 3D, 4D, 73D, etc. All kinds of cool stuff. We're going to look at the math. This is going to be a little bit more advanced, and we're going to move a little bit more quick. So stay with me. If any of this is too fast, check out the videos before this where we go through straight lines from like basic principles. Jump into the code. As always, there'll be a link in the video description to follow along. I'm going to move pretty quickly here. So I'm going to do function setup and going to create my canvas. I'm going to create it with window.innerWidth and window.innerHeight. Height, there we go, okay. And then I'm going to do function draw, and inside of draw I'm going to say background black. In this case I'm just going to do 0, because 0 as well will come out the same as black. And then I'm going to say strive.draw tick axes in order to get our grid lines. Click that save button, and now we get some beautiful tick lines coming on to the screen. Okay, first things first, we want to get this coordinate system looking a little bit more like the regular math coordinate system. The way we do that is through translate and scale. So we do strive.translate in order to translate our origin to width over 2, height over 2, width, not width, width, okay, width over 2, height over 2. And then we need to as well, oh, why, okay, that's just being silly. Height 2, okay, it should go away now. And then we as well need to do strive.scale in order to flip the y-axis. So I'm going to 1, -1. So I multiply all the points in the y by -1. And now we get a regular kind of thing. Awesome. Okay, now I want 2 movable points. So what I'm going to do is I'm going to say let P1 and P2. And then inside setup, I'm going to say P1 is equal to strive.create movable circle. And I'm going to say whatever that starting position, 100, 100, let's give it 20. And I'm going to go P2 is equal to strive.create movable circle. And let's put this at -100, -100, 20. And then inside of draw, I'm going to say P1.draw and P2.draw. P1.draw, P2.draw. So we declare our points, we initialize them in setup, and then we draw them over here. So now we have these 2 points, P1, P2. Cool. Now we want to do a straight line going through them. So we know we have the equation of the form y is equal to mx plus c. And we know the following. M is equal to change in y over change in x. And c, we could solve. So if we solve for c in this equation over here, we get c is equal to y minus mx, right? So we simply take mx over the equal sign and get c is equal to y minus mx. M, that's going to be y2 minus y1 for any of the points for change in y, over x2 minus x1. Awesome. Okay, let's put this all into code. So let c is equal to y minus mx. Okay, so actually first let's work out m, because we need to get that m first before we can work out the c. So m is equal to y2 minus y1. So that's going to be p2.y minus p1.y over p2.x minus p1.x. And then C is going to be Y. So let's just choose one particular Y coordinate for this. So let's go P1.Y minus our M times by P1.X, right? So we chose this particular coordinate, P1Y, P1X, okay? Now we want to calculate, we now have the equation of the line, we want to calculate the coordinates at the extreme ends of our screen. So we can say let x min, that's equal to negative width over 2, because that will be all the way on the left side. And we can say let x max is equal to positive width over 2, be all the way on the right side. Let y min is equal to, now we just plug it into the formula, right? Into y is equal to mx plus c. So we say x min times by m plus by c, and we say let y max is equal to x max times by m plus by c. And now we draw a line from those points. So we go line and x1 y1 x2 y2, so y min x min and y max x max. Okay, super quick, right? If this is too fast, oh, actually, this needs to be y1, y2. Yeah, that should work. Okay, it's all in black. So let's get a nice red going. We're going to go red, and we're going to increase its thickness. Stroke weight 2. Okay, speed coding here. There we go. Okay, we have a... Oh, Oh, there, that's why. X max, Y max. Oh, Y max. Okay, come on. Show me the money. And you should work nicely, please. Why? Why you gotta be like this? Oh, it's a line. X1. Let's P5 JS. See, this is what happens. Maybe this will be useful because now you can see how I am doing it. Oh, okay, sorry, it's x1, y1, not y1, x1. So x min, y min, x min, y min, x max, y max. Okay. Please. Okay, cool. We have our straight line working. Okay, now let's just create a random point, right? Let's go P3x is equal to, where should we put this bad boy? Let's put him at 150. Okay, and then I'm going to say let P3y, I'm going to put him at negative 100. Okay, go away, Siri. We don't need you around right now. And unexpected token. Why? Okay, well, maybe it's an error from something else. Sometimes CodePen can be a bit weird. This is our point. Let's get a circle there. So I'm going to say circle at P3x, comma P3y. And let's make it as well 20. Okay, cool. So now we have that circle over there.